about the most. So let me tell you an open question that I've been, puzzling over for the last year or so. So given a quantum circuit C, let's call it peaked. If, when you apply this circuit to the all zeros initial state, and then you just measure each qubit to see if it's 0 or 1, then there's some particular output string that occurs with a really large probability, like more than 1/10, let's say. Okay, so there's something that sticks out like a sore thumb about the output state that makes it very, very easy to recognize that this is not just a random quantum state. This is not just some random garbage. So now I'm going to ask the following. Suppose that I pick a random quantum circuit, which is just the kind of thing that's done in Google's and USTC's existing experiments. But now I condition on the event that that circuit is peaked. So I just throw away all of the quantum circuits that are not peaked, and I keep only the ones that happen to have this special property. Okay, now my question is, what does a random peaked quantum circuit look like with, let's say, n qubits and n squared gates or something like that? Okay, and you can imagine two extreme possibilities. One is that such a circuit would be essentially trivial. Okay, so it might consist of a whole bunch of gates followed by the inverses of those gates, right? And so then even with your classical computer, you could examine the circuit and say, yes, clearly this is peaked because it's not doing anything interesting. It's just computing the identity, right? A second extreme possibility would be that the circuit looks, for all the world, like just an arbitrary random circuit. You can't see any structure in it with your classical computer. And yet, when you ran it on your quantum computer, you would see this particular outcome X, pop out with high probability. Now, in the latter case, what this would be telling us would be that the kind of quantum circuits that we need for near-term quantum supremacy experiments that are verifiable, would at least exist. Okay, they would be out there, platonically, waiting to be found, right? Namely, these circuits that look random, but that secretly choreograph this interference pattern that concentrates all this amplitude on a particular outcome, right? And that would leave only the problem of how do we find the circuits. It would reduce the question to that one. Okay, because if we could find these circuits, then we would have our near-term quantum supremacy experiment. Namely, I give you a circuit, let's say either it's a completely random circuit or it's one of these random peaked circuits, and I ask you to decide which it is. Right, and by assumption, a classical computer would not be able to solve that problem, but a quantum computer would, and you could easily check that the quantum computer had succeeded. Okay, so there are many related questions one could ask.